Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello there. Hello. Lesson 15, the angle AA criterion for two triangles to be similar. Notice it says similar, not congruent. Classwork exercise. Draw two triangles of different sizes with two pairs of equal angles. Then measure the lengths of the corresponding sides to verify that the ratio of the lengths is proportional. Use a ruler, compass, or protractor as necessary. Okay, let's dive right in there then, and let's go get my ruler. I'll start with the ruler, and I will draw a segment. Let's see, I'll draw a 5 centimeter segment, and I'm going to label this up as I go. So this is A and this is B, and the length of AB equals 5. I'm not going to worry about unit of measurement right now. It is centimeters. AB equals 5. And then I'm going to take my protractor and I'm going to make a 30-degree angle. So 30 is right here. So it's going to come up to somewhere around there. And then I move my protractor and I bring my ruler back. Rotate. And then I am going to draw a line segment. Let's make it 3. There's 3. And I'm going to call that C. So if I call this, why am I writing an A? C. AC equals 3. And then I'm going to put my ruler at 0, rotate it, and then finally draw my last side down to B. And that is a length of 2.8. So BC equals 2.8. So there's my first triangle, side lengths. Angle A is 30 degrees. So I should probably add that for this triangle. The measure of angle A equals 30 degrees. The measure of angle. So now I'm going to measure the another angle. How about B? Let's see what B is. Or actually, let's do C because it's obtuse. So put my protractor at C. The crosshair is at C. I'm going to rotate it so that the 0 line is on CA. And then I measure out, and if I take my tool, where is it? All right, let's make that smaller so it appears. There we go. Struggles are real. All right. Grab this, bring it around, line it up with my side. There it is. It is 119 degrees. So the measure of angle C equals 119. Okay. I can find the measure of angle B now just by the triangle sum theorem, but we're not going to worry about that because this is angle. I have two angles. So there is my first triangle. So it says to draw two triangles of different size with two pairs of equal angles. All right. So let's make one twice as big just to make it easier. So then I'll make this one green. And AB is going to be, since AB was 5, I'm going to make AB 10 this time. And I'm going to call it A prime, B prime. So this is A prime. This is B prime. And over here, I'm going to say A prime, B prime equals 10. So I see that it's a scale factor, R equals 2. And that's what I'm going to follow to do this example. So I'm going to rotate this now to 0. I'm going to put it at A, which is right there. I'm going to erase that and switch to arrow so I can do this. And I want 30 degrees, which is right there. So I'm going to put a dot somewhere out here, right at 30 degrees. Move my protractor, draw segment A prime, C prime, and it should be 6 long if it's going to be a ratio of 2. So let me draw. What happened? My speakers changed. Why did that change? Is this louder or quieter? I will find out when I hit play. So A prime, C prime, here's C prime, is 6. Okay, so then if I make another angle, put this right at C, rotate it so that we're right on A, like so. Move this around to 30. I'm sorry, not 30, 119, which is right there. So my 0 is at C prime. A prime, C prime is right on my 0 line. So this out this way is 119 degrees. So if I draw a segment out to here of 119, then these two triangles will be similar. Okay. So A prime, B prime equals 10. The measure of angle A prime equals 30 degrees. The measure of angle C prime equals 119 degrees. Okay, so I kind of cheated here by doing the R equals 2 and drawing the lengths, but I'm going to do something after to prove that this will work for any. Okay, so now that that's done, if I measured B prime, C prime, it should be twice as long as BC. The measure of angle B should equal B prime. So that's how I'm going to check to see if this works. The other thing I'm going to also do is I'm going to put my protractor back on that A prime, C prime segment, and anywhere, it doesn't matter. How about right here? And I'm going to draw another segment of a different size triangle at 119 degrees. And what I'm going to do now is I'm going to draw a segment from here to here. Okay, so there is, I'm going to look at this smaller triangle now. And if I put my protractor here, I made it 119 degrees. The measure of angle A prime is already 30. So now I'm going to measure, let's call this D and this E. So the measure of DE, whoops, the measure of DE equals, and when I measure it with my ruler, I get 4.3. So that is 4.3. And if I measure CB, that is 2.9. So BC equals 2.9. So here is our scale factor of the triangle that doesn't include this big side, but this dashed side. And 4.3 divided by 2.9 is approximately, because 2.9 is prime, if you will, 4.3 divided by 2.9 is 1.48, almost 1.5. So that's almost a 1.5 scale factor. So then I would have to compare another side to it. So here's AB. AB's 5. A prime D is 7.6. So 7.6 divided by 5 should come out to be that same fraction amount, pretty close. So if I take 7.6 divided by 5, I got 1.52, which is really close to 1.48. I'm off by 4/100ths of a centimeter. Okay, that is 4/10 of a millimeter. So the scale factor is 1 to 1.5 roughly. And if I went back to my large triangle, A prime B prime has a length of it's 10. It is 10, and 10 is twice 5. Okay, the measure of angle A is 30 degrees. I made that with the protractor. This here is 119 degrees. This was 119 degrees. And this is 119 degrees. So I just showed you, I even made another side to make a smaller triangle. Triangle A prime ED has a scale factor of almost 1.5, and A prime B prime C prime had a scale factor of 2. So they're proportional, and all three of these triangles are similar because we have two pairs, or we have a pair of congruent angles. 30, 30, 119, 119, 30, 30, 119, 119. Are the triangles you drew in exercise 1 similar? So there I would say, yes, they are similar. They have the congruent angle measures and proportional sides. Okay, so you should verify that you have drawn a pair of triangles with 2 pairs of equal angles and have shown via direct measurement that the ratios of corresponding side lengths are, in fact, proportional. Why is it that you only need to construct triangles where 2 pairs of angles are equal but not 3? Okay, well, the answer to that is the triangle sum theorem. All triangles add up to 180 degrees. So if I have 30 and I have 119, that adds up to 149. So angle B has to be 31, okay, in both cases, because no triangle on a plane has less than 180 or more than 180 degree total angle measured. So how would you word that? Word is right here. Yes, the triangles are similar. The converse of the theorem is similar in triangle. Let me see. Am I in the right place? Okay, this, let me get rid of that, is for this. So you'd say, yes, the triangles are similar. The converse of the theorem on similar triangles states that when we have 2 triangles, triangle ABC and A prime B prime C prime, with corresponding angles that are equal and corresponding side lengths that are proportional, then the triangles are similar. Then it says, why do you only need 2 angles? And the reason is, drum roll, please. And If we are given the measure of two angles of a triangle, then we also know the third measure because of the triangle sum theorem. All three angles must add up to 180 degrees. So showing two pairs of angles are equal in measure is just like showing all three pairs of angles are equal in measure. Why were the ratios of the corresponding sides proportional? Well, that's a lengthy explanation, but I have it right here. Since the triangles are similar, we know there exists a similarity transformation that maps one triangle onto another. Then corresponding sides of similar triangles must be in proportion because of what we know about similarity, dilation, and scale factor. Specifically, the length of a dilated segment is equal to the length of the original segment multiplied by that scale factor, which we did in a couple of lessons. So in other words, side A prime, B prime, okay, my base from here all the way over to here without this dash line, without this D and E, okay, A prime, B prime divided by AB should equal 2. A prime, B prime was 10, AB was 5, 10 divided by 5 is 2. That is our R, and A prime, B prime equals R times AB, 2 times 5, 10. All right, page 2, problem number 5. Do you think that what you observed will be true when you construct a pair of triangles with two pairs of equal angles? Explain. Well, I'm going to leave that to you because it's a do you think, so it's a hypothesis before we're going to do the study, and then we'll conclude whether or not your hypothesis is true or not. So I'm not going to do 5. I'm not going to tell you what I think. Number 6, draw another two triangles of different sizes with two pairs of equal angles. With two pairs of equal angles. So it is going to be a triangle with two equal angles. If we remember, opposite sides of equal angles are equal. So that's an isosceles triangle. All righty then. All right, so here we go. I'm going to draw two triangles with two angles that are equal. So the first thing I'm going to do is I'm going to draw a segment. How about one with solid line? Okay. Let's use purple this time. So I'll start at 0 and I'll draw a segment that's, I don't know, 5 again. Very close to 5 right there. All right. And you know how to use a protractor now, so I'm going to speed this up. My ruler is a protractor, if you will. So if I rotate this, I can see how many degrees I'm rotating it. And I'm going to make it 40 degrees. Nice round number. And I'm just going to draw this up like so. Okay. Now I'm going to take my protractor. And make another angle of 40 degrees. So if I rotate this around and line it up as close as I can, that looks parallel right there. Maybe a smidge this way, like that. And I can put this anywhere. I want a 40-degree angle, so I'm going to come down. So as you can see, here's 0, 10, 20, 30, 40. 40 is right here. So as long as I can keep that 40 from going off, like if I went way up here, that 40 degrees, as you can see, will not hit that side. So I don't want to go that far up. So I'm going to move it down so I do intersect the other side. So 40 degrees is right here. So that would end up somewhere out here. So I take my ruler. One thing I forgot to do is mark my line segment so I don't know where that 40 goes. So how about I do this again? let's put a dot. So let's call this A right here. And how about B right here? And then I will put my compass, my protractor, I mean, right there on B. And then I'll put a dot down here for 40 degrees. Okay, just to the left of that little mark I put there. Then I bring my ruler, come on, bring my ruler over, put it just to the left of this mark that I made, rotate it up to B, and draw my segment. Okay, and then I'm going to erase my sides down to those vertices. And there's my triangle. So the measure of angle A, 40 degrees. The measure of angle B, 40 degrees. C has to be 100. It is more than 90. It looks like 100 degrees. Okay, so there is my initial triangle. It says draw another 2 triangles of different sizes with 2 pairs of equal angles. So now I'm going to draw a bigger one. I'm not going to measure though this time. So I'm just going to, let's use blue for this triangle. So I'm just going to draw a line and I'm going to measure it. I'm going to put my protractor on it. At 0, put this right at the end point. 40 degrees is, let's make this larger. 40 degrees is right at this 140 outside. So that would be right about, well, actually, let's do this. I can probably draw a line to it, through it. So if I line this up to 40, like so, draw a segment down to that vertex right there. So there's a 40-degree angle. Obviously, you can't do that in the real world. Your pencil will not work through a protractor, but so that there is A prime. Okay, so then I'm going to rotate my protractor. I'm going to put it aligned with this blue line. That looks about right there. And then I'm going to take my ruler and I'm going to draw a line segment that's at that 40 degrees. See how that lines up with 40 right there? So if I drew a segment like this all the way up to there, move my protractor, move my ruler, erase, erase, and erase. Okay, so there are 2 triangles. They should be similar. The measure of angle A prime and B prime, I just did that, so I don't need to measure them. I used a tool to make it. I don't need to remeasure it. Those are 40 degrees and 40 degrees. Because of that angle C prime has to be 100 degrees. I don't even have to measure that. Okay, so what are we trying to prove? That they're proportional. So R has to equal AB over A prime, B prime. So then I'm going to measure these, and that will be our R. So now if I put that right there and bring that down, that is 55, 56, 57 millimeters. So that's going to be 5.7 centimeters. Do the same for A prime, B prime. Remember, I did not measure these to make it like I did on the last page. And this is 51 to almost 53 millimeters. So let's put They're very close to being equal, by the way. I should have made one a lot bigger or smaller, but they are not equal. Okay, so I'm going to use my calculator because of this, and we're going to look at the decimal. So 5.7 divided by 5.3 is our R. Whoops, why did I do 3? 5.7 divided by 5.3, hello, 1.075. Okay, so that's going to be approximately 1.075. Okay, so then I'm going to do the same with the next two sides. So I'm going to measure AC, which looks like it's 38 millimeters. Okay, 3.8. So then my R has to equal AC divided by A prime C prime, which equals 3.8 divided by A prime C prime, which is 3.4, something like that, 3.4? 3.4. Roughly. 3.8 divided by 3.4 equals 1.117. Okay, 1.0, 1.1, we're off by less than a millimeter, 0.07, 0.11, that's 4/100ths of a millimeter. I believe that's close enough for high school work. All right, so then when I measure this side is 3.6. So R has to equal BC divided by B prime, C prime, and BC is 3.6 divided by, and then I bring C prime, B prime measurement into this, and it's 3.4. 3.4. 3.6 divided by 3.4 is 1.058. Approximately. So 1.05, 1.07, 1.11, it's all within a couple 100ths of a millimeter, or centimeter, I should say. A couple tenths of a millimeter, which is pretty darn close. So my R is, I would say, equal in all three cases. All right, so number 7 says, are the triangles shown below similar? Explain. If the triangles are similar, identify any missing angle and side length measures. So we just did the proving of this, and now we're going to apply it. And that's where I really enjoy math, is taking what we know about the theorems and applying them to real situations. All right, so the first thing I need to do is determine what angles correspond with what angles. I will label that up. 78 is more than 57. 57.12 is congruent to this. So I'm going to call that A, and I'm going to call that A prime. Okay, well, if they're similar, angles have to be congruent. So let's call this B and this C. So B is 44.42 degrees. So this must be my B because this is not equal to that. Does that make sense to everybody? And that has to be C prime, B prime. So the first thing you want to do is identify which angles and which sides correspond. All right, so angle A is congruent to angle A prime. The next thing I need to do is my triangle sum theorem. So let's do triangle ABC. So the measure of angle C equals 180 degrees, the sum of the triangle, minus the measure of angle B minus the measure of angle A. So the measure of angle C is going to be 180 minus 44.42 minus 57.12. And since these are decimals and we're on a timed video, I will speed this up by using my calculator, but I would not in the real world. I would do this manually. Minus 44.42 minus 57.12, and I get 78.46. So the measure of angle C by the triangle sum theorem is 78.46 degrees. And notice that that is equal to C prime. So 78.46 degrees. So the first thing I had to determine is, did we have two angles congruent? 57.12, 57.12, 78.46, 78.46. We have an angle-angle similarity. I do not need to do my calculation for B prime. With these two measurements, I know it's 44.42. Got it? Good. Okay, so now we need to see if proportional sides exist. So AB divided by, or I should say compared to, A prime B prime has to equal BC compared to B prime C prime, and they have to equal some R. That's what we're checking now. So let me get this out of the way. All right, so let's calculate that. AB, 7, divided by divided by A prime B prime. A prime B prime is right here, 28 over 3. So 7 divided by 28 divided by 3. I'll put that in parentheses just so we know that's our denominator. 28 thirds has to equal BC, which is 6, divided by B prime C prime, which is 8, has to equal R. And 6 over 8 is 3 over 4 reduced, which is 0.75. So I just need to determine that 7 divided by 28 thirds is 0.75. I'm not using my calculator. I need to remember that when I divide by a fraction, you can multiply by the reciprocal. So 7 divided by 28 thirds is the same as 7 over 1, if you will, times 3 over 28. And 7 times 3 is 21 over 28. And 7 will go into 21 3 times, and 7 will go into 28 4 times. And we do have 0.75. So we have a similarity. So angle A is congruent to A prime, angle B is congruent to B prime, and AB is to AB, A prime B prime is to BC, as BC is to B prime C prime, which equals our R of 0.75 or 3/4. So yes, these triangles are similar. Okay, page 3 brings us to exercise 8. So try this on your own, pause the video and see how you did. So here we go. Are the triangles shown below similar? So remember, similar, we need AA, and sides have to be proportional. In other words, we need an R. Okay, so I'm looking at this triangle. Angle B, 95 degrees. Angle E, 95 degrees. Check. We have one angle congruent to another angle. We have an A. Uh-oh. Angle A is 25 degrees. Angle F is 24 degrees. So 95 plus 25 is 120 degrees. C is going to be 60 degrees because of the triangle sum theorem. D is going to be 61 degrees because of the triangle sum theorem. We do not have a second A. No, these triangles are not similar. We do not have angle-angle congruence. Okay, number 9. The triangles shown below are similar. They're telling us they are similar. Use what you know about similar triangles to find the missing side length X and Y. First thing I'm going to do is label this vertice A. Then I will label this gray marked angle B. So this will be B prime. And this is A/A prime. And this will be C. So therefore this will be C prime. First thing you should do is label vertices so you aren't confused with how your setup is going to be. So the reason they are similar is because vertical angles are congruent. So we have the measure of angle A is equal to the measure of angle A prime. The measure of angle B is equal to the measure of angle B prime. We were given that by these marks and knowing the vertical angle theorem. Okay, so we have angle. We need proportional sides. So that's why I like naming them. So you have to use the given side to set up your proportion. So our R is going to equal, and I'll put the one that we know both components to first. So AB is 4. Let me put it in words first, letters first. We're going to compare side AB to side A prime, B prime. And those should be equal to BC compared to B prime, C prime, and then AC to A prime, C prime. So that's what we're going to do. So our R is going to equal AB 4, A prime, B prime 12 equals BC over B prime, C prime. Okay, equals AC 3.14. Doesn't look like a 4. 3.14 divided by A prime, C prime, A prime, C prime, Y. Okay, so you're looking at this and you're probably thinking, wait a minute, there's two unknowns, we can't solve this, okay? Well, these are all equal, so if I focus on this first, I can find X by cross multiplying. So 12 times X equals 16.5 times 4. So 12X equals 6 times 4 is 24, carry the 2, 26, carry the 2, 4 times 1 is 4, 5, 6, 66.0. 16.5 times 2 is 33, yes, that's correct. Divide by 12, divide by 12, X equals 66 divided by 12. 5 1/2, okay? 5.5 or 5 1/2 or 11 halves, okay? All right, so then we're going to focus on, see this 4 12ths here? We're going to set 4 12ths equal to 3.14 over Y. So really what I should have done when I set this up, when you're doing this, in hindsight, I would have put the given one that had 2 given sides in the middle, and then it would line up nicer. So anyway, we're going to cross multiply. 4 times Y, 4Y. 12 times 3.14. Okay, calculator. 3.14 times 1, 2, enter. 37.68. 4Y equals 37.68. Divide by 4, divide by 4. Y equals, I hope it's 5.5. So 37.68 divided by 4, 9.42. Okay, so now we need to check our answers just to be sure. So in order to check that, I would take 3.14 divided by 9.42, 3.1 divided by 9.42, enter, and I got 0.33333333. 4 divided by 12, 0.33333333. 5.5 divided by 16.5, 0.333333. So our R is 1/3. R equals 1/3. It's true for this. It's true for this with X being 5.5, and it's true for this with Y being 9.42. That's how you check to see if you're right. Your R's all have to be equal. All right. So Y is 9.42 and X is 5.5. Page 4 brings us to problem 10. Try this, pause the video, see if you can do it, and come back. All right, now it says a triangle shown below are similar. They told us this angle is equal to this angle. They didn't tell us this was equal to this, but this angle right here is shared in both triangles. So by the reflexive property, this is going to be angle A, which is equal to A prime. This is going to be angle B, and this is going to be angle C. So this is B prime, the little triangle, and this is C prime, the little triangle. Okay, so we're told they're similar, so we know that we have an angle equal to an angle equal to an angle. Two angles are congruent to their corresponding angles. Great. So therefore, they must be proportional. So I want to compare sides. So R has to equal, and I'm going to put the givens, the two givens, which is A prime, B prime, and A prime or AB, 3, 6, we already know that, in the middle. So I'm going to say BC is to B prime, C prime, as AB is to A prime, B prime, as AC is to A prime, C prime. Then I'm going to insert my givens. BC is right here, 12. B prime, C prime is my X. That equals AB, which is, now be careful here, this little piece is 3, this big piece is 6, so the whole thing is 6 plus 3, which is 9, over A prime, B prime, which is 3. Be very careful there. Most students would look at that and say, oh, it's a 2-to-1 ratio. No, it is not. It's a 3-to-1. Equal to AC. AC is, now be careful again, 2 plus Y, not 2 times Y. Most common mistake there is multiplying. We do not multiply pieces to get wholes. We add them. 2 plus this Y equals the whole thing, 2 plus Y. Divided by A prime, C prime, which is just this 2. Okay? So be very careful setting this one up. So R is equal to, well, I already know R is 3. Okay? So R is 3. 9 divided by 3 is 3. So now this is what I mean by putting what you know in the middle. Then you can do this, and there's your cross multiplication problem. And so you would say, let's get rid of this for now. Let's just solve. So at 9 times X is 9X equals 12 times 3. 9X equals 36. Divide by 9, divide by 9. X equals 4. So that is 4. Then I come over here and I use this middle with this. So I cross multiply. Be careful. Make sure you distribute. 3 times 2 is 6. Plus 3 times Y is 3Y. Equals 9 times 2, 18. This is where your algebra is going to be really important in geometry. If you didn't get this algebraic distribution, all that stuff from last year, this is where geometry is going to start getting tough. So you need to know your algebra to do your geometry. So then I subtract 6 from both sides. I get 3y equal to 18 minus 6. Divide by 3, divide by 3, and y is also 4. Okay, I'm going to check. So I have the whole thing. So if AB is to A prime B prime is 9/3, then my other one, my BC, is 12 over B prime C prime, which is 4. Well, 12 divided by 4 is 3. 9 divided by 3 is 3. And then finally, right here, take my 2 plus my y, which was also 4, over 2, and that is going to be 6/2, which is also 3. So my r is 3. So the length of x is 4, and the length of y was 4. Okay, page 5 brings us to the end of lesson 15. Finally, we're doing some math. We're doing some applied problems, which is a lot better than proofs, and figuring out what theorems we can use to do this math. So enjoy. This is the end of lesson 15. Go do your problem set.